Hello and welcome in. Mark here, aka the Markster. This is video number 91 in the free CAD series. Today we're going to be looking at the PDWrapper macro. And I'll be using one of the weekly builds, 0.20, revision number 2737 plus 1. So PDWrapper is a macro, and the PDWrapper stands for Part Design Wrapper with a W. And that's used in Part Design Workbench to allow you to use solids created in other workbenches inside your Part Design body. It can do some other stuff too besides that, but that's what we're going to focus on today. It's just using it to get solids from other workbenches into the Part Design body. So let's create a body. I'm going to go into Part Workbench, and I'm going to make a tube primitive. Since we don't have tube primitives in Part Design, I thought that would be a good example to use. And let's make a sketch on the XY plane, and we just have a little rectangle here, something to use for a pad. And I'll make that symmetric to the plane, 4 millimeters. So it's 2 millimeters above and 2 below. And I'm going to position this tube. Right click, choose transform. Just drag it back here to the back corner. I'm not making anything particular, just demonstrating here. So the tube is not in the body yet. We can add it to the body in a couple different ways. You can drag it and drop it into the body, and it becomes a base feature. But there are some limitations with that. And the PDWrapper enables us to work around or avoid those limitations. So let me drag it into the body and watch what happens. You see it moved it back to the center. It's in the body, but it's not where I wanted it at. So the base feature does not respect the placement of the encapsulated object, or the source object. The base feature's base feature is not, the placement of that object is not respected. Another limitation of the base feature object method is there can be only one base feature per body. So if I had another object that I also wanted to bring in, I could not do it in the same body because you can only have one base feature per body. It also follows logically that since the base feature has to be the first feature in the body, it cannot be a subtractive feature. So base features all have to be additive features. They'll have to add to the body because they're the first feature in the body, and at that point there's nothing that you could there to remove. So a pocket cannot be the first feature in the body because there's nothing there to pocket. So limitation number 1 is you can only have one base feature. Number 2, it must be the first feature in the body. And that means in number 3, it cannot be a cutting tool. And number 4, it does not respect the placement of the encapsulated object. And limitation number 5, it cannot be used as the base of a pattern feature. For example, a linear pattern. So if I selected this base feature object and ran the linear pattern tool, I get this error. Only additive and subtractive features can be transformed. Base feature cannot be used in a linear pattern feature or a polar pattern or a mirror. So base feature is fine for many cases, but it's not fine because of those limitations. So I'm going to delete it, and I'm going to bring it in with the PDWrapper macro. Now you need to install PDWrapper if you haven't already. Go to Tools menu, Add-on Manager. Make sure you're in the Macros section or All. You can enter PDW, select it, and up here to the right you'll have Install. I have Uninstalled because it's already installed. You'll have Install. If you're using 0.19, the add-on manager will look a little bit different, but it functions basically the same way. Once you get the macro installed, you go to Macro menu and Macro section here, and you have a list of all your installed macros. You can see I have quite a lot. And you'll find here pdwrapper.fc macro. First time you run it, it's going to create this file here, pdwrapper.py, with your permission. You do not run the py file. That's imported by the macro file and by FreeCAD when you open a document containing a PDWrapper object. Without that file here, without this py file, that object would be broken if you restarted FreeCAD and opened a document containing one of those objects. So then we run the macro with the tube selected, and it's going to ask you which type to create. And we have several options here: additive, subtractive, common additive, common subtractive. Don't worry about all these. You can learn about them in time. Exclusive or additive, exclusive or subtractive, and none. And today, in this example, we're going to use additive. And we also get to choose where to put the object in the tree. So which object should come before the PDWrapper? So it could go either to the beginning of the body or after the pad. So with the base feature, it had to go to the beginning, but with the PDWrapper, we have a choice of where to put it. And I'm just going to put it after the pad. And you see that PDWrapper respected the position of the tube. We can also use the PDWrapper as the base of a linear pattern. We choose here and select a reference. Choose this base horizontal base x-axis, and we need to make this some smaller number here. Let's try 35, and we need to reverse the direction. So you can see that PDWrapper has overcome a number of limitations in the BaseFeature object method. All 5 of those limitations. We can also use the wrapper to make a subtractive object. Let me delete that and get back to where we were, and I'll show you a subtractive example. So select the tube, run the macro. This time we'll choose subtractive, and we'll follow the pad, and you see now the tube has been cut out. It's been used as a cutting tool to cut out of that pad. And of course we could use that also in a pattern feature. I don't want to get too detailed in this first video, but we covered kind of the basic thing here, which is bringing objects that are not part design solids into the body using the PDWrapper. But it has some other capabilities too that I would like to touch upon. Let me remove these warnings here. So here we select the PDWrapper in the tree, and you can see it has a number of properties here. And we have pattern shape section, placement adjustments section, tip shape section, and user interface section, in addition to the PDWrapper section. And in the user interface section, we have show mesh props, which is false. So what's that about? Well, you can encapsulate mesh objects as well, and it will convert them to a solid and bring them into the body. So we have properties for mesh objects that we could show, but since we already have a lot of properties in here, I've disabled that by default. Show offset props is also disabled. Show scale props disabled. Show warnings is true. So let's enable show offset props. And now we have new properties added. We have pattern offset section and tip offset section. Same could be done for the scaling properties. Now we have tip scale and pattern scale. So there are a bunch of properties in here, And this user interface section lets us trim some of those away so that it's not so overwhelming with so many properties. So what does offsetting and scaling do? Well, this is 3D offsetting. So we set that to true. And we have the tip offset. So we can set tip shape offset to 1. And that makes this tip shape offset. Should probably make it an additive so you can see better what's going on. Let's bring it in as an additive. Okay. And now we'll do the tip shape offsetting. So in the tip shape section, in the tip offset section, we've got tip base offset, tip offset cut, tip offset intersection, tip offset join. Don't be afraid. This will all become familiar at some point if you continue using the macro. We've got tip tool offset, tip shape offset, tip base offset. I want to focus on these 3. So to make the tip shape, and the tip shape is what you see on the screen when the object is visible. It's when it's the body's tip, so the body has a tip property. When the shape is the body's tip shape, then the tip shape is the shape that the body takes as its own shape. So that's why I call it the tip shape. It's the shape of the body when it's the body's tip. That's the tip shape. The pattern shape is the shape used to make the patterns. So if we make the linear pattern, again, I'll just make 3 of these. Alright, so the shape that was used to make the patterns is the pattern shape. It's sort of the intrinsic shape of the tube. But the tip shape is the entire thing. It's the tube and the pad because it's fused to the pad. Or in the case of a subtractive, it would be cut from. So we have this thing that I call the solid feature chain in a body, and that includes all the solid features in the body. They're either fused to the previous feature or cut from the previous feature, which is the base feature property of each object. So each of these objects has a base feature property. If I right click here and choose show all, it's hidden by default. See if I can find the base feature property. You see the base feature of the PDW object is the pad. It's the one that comes before it in the tree. You got pad and then PDW add, and the base feature property is the pad. For the linear pattern, its base feature is the PDW add. And the pad does not have a base feature because it's the first object. So it can be confusing because there's a BaseFeature property and there's a BaseFeature object if we brought the tube in as a BaseFeature object. It's not my fault. I didn't make up those names. So we have two shapes with each object. You have the tip shape and you have the pattern shape. And FreeCAD keeps track of both of these shapes for us. Okay, so shape is the tip shape. Add subshape is that pattern shape. It's the intrinsic shape of the object. The add subshape is only the tube. The tip shape is a tube fused to the pad. The linear pattern uses the pattern shape to make the copies. If it used the tip shape, you'd have the pad also duplicated 3 times over. So with the PDWrapper, let me hide those now. We can offset each of those shapes individually. We can offset the pattern shape and we can offset the tip shape. So let's do the tip shape first. We can use tip shape offset, and I'll just set 1 and see what happens there. 1 was a little bit too much, I guess. No, we don't want to do the tip shape. The tip shape is the whole thing. We want to do the tip tool. The tip tool, there we are. The tip tool is the tube. So if we look here at tip shape section, you've got the recipe for making this tip shape. We take the tip base as the pad, tip tool is the tube, and the tip operation is a fuse. Well, we also have a couple of options here to use the tip bases add subshape, the pattern shape of the tip base, which is the pad. Or we could also use the tip tools add subshape. So we can use the tip tools pattern shape in this Boolean operation. These are false by default for the additive types. But we can refer to this section to see which is the tool and which is the base. And in this case, the tool is the tube. So we want to offset the tube, not the base. And not the shape. The shape is the result of that recipe, the Boolean result. If we do the base, you see the base is now offset. So we could do them both actually. And if you offset the tip shape, that's the result object. If you set 0, you don't get any offset. But it failed when we did both. I'm not sure why. Maybe it's too much. Yeah. So 0.25 works. 0.5 works. 0.1 was too much for some reason. But notice that these these linear patterns were not offset because we're only doing a tip shape here. But we can do the pattern shape in the pattern offset section. And remember the tool, look at the pattern shape here section. The pattern base is a tube. So that's what we would want to offset. Pattern base offset. So now we have those offset by 1. And if we come down here back to tube section, it's shaped to 0. We can put base to 1 if we want to hit 1. And tool to 1. So now they're all the same. So we have 3D offsetting in part design. Previously that was only available in part workbench. Now with these offset sections, we have some different options for offsetting. Arcs, tangent. Some of these will fail. See, that one failed. For some reason, arcs is more robust. So that's why it's the default. It works when the other ones fail. Tip offset cut. So what that means is the original object is cut from the offset. So you can think like chocolate Easter bunny, hollow chocolate Easter bunny. That's kind of what you're making when you set offset cut to true. I don't know if it's going to work here or not. It did. And if we use clipping plane, you can see here, can you, that the inside was cut out of these by having an offset cut to true. Set it to false, and it's not cut out anymore. It's hard to find it, but it's so small. You can do the same for the patterns. True. And clipping plane. It's hard to see, but you can see that it has now a thickness to the wall. So we also have the mode, which can be skin, pipe, or recto verso. And we have self-intersection. These are all documented in the part workbench. So if you use the 3D offset, you have these same options. So that's going to do it for this video. I think we covered a pretty good bit. Still a lot to cover. But you can bring solids in from other workbenches to use them as you would use native part design objects with the PDWrapper macro. It overcomes some of the limitations of the BaseFeature object method. It also enables you to do some cool things like scaling and offsetting your objects using the PDWrapper. It offers multiple PDWrapper types. We looked at additive and subtractive today, but some of the other options, a common type, exclusive OR type, probably not going to be as useful as the additive and subtractive types, but they're at least there. And the none type is also quite useful, and I'll most likely cover that more in future videos. With the none type, you can disable features in the tree interact dynamically. So we'll cover some of that stuff in some later videos. I'm sure I'll do more on the PDWrapper, but I want to keep this around the 30 minutes or so length, which is where we're at right now. So thanks for watching, and I will see you in my next video.